All right, so let's see this particular question now. Next greater element, right? So in this question, we are given an input array of integers, and our task is to find the next greater element for each element of the array in order of their appearance, right? And if there is no such element that exists, we can just return -1 for that particular element, right? So I'm pretty sure you did not get it, right? So maybe what I can do is I can take the example of this input, right? So what they are saying is that for every number in this particular array, I have to find out the next immediate greater element, right, than this current element, and that I have to list down in my output array for that particular element, right? So for example, if you see for 4, the next greater element is 5, right, the very next element. So in my output, I will have 5 in this particular position, right? Now for the next element 5, right, the next greater element, the next immediate greater element, if you see, is 9 over here, right? And so I will have 9 in the second place, right? Now for 2, if you see, I have the next immediate greater element as 9 itself, right? The very next element. And so again, I have 9 in the third position, right? For 9, if you see, the next immediate greater element than 9 is straight away this, right? 10, which is the last element of the array. So in this position, I have 10 now, right? Similarly for 7, the next greater element is 8. For 8, again, the next greater element will be 10. For 6, also it will be 10. And for 10, since there is no number next to 10, it will be -1, right? So that's what we have to do for every number in this particular input array. We have to find the next immediate greater element, and that immediate greater element we have to output in our final resultant array, right, for each of the number, right? And if there is no greater element for a given number, right, if for example a given number is the greatest element in the entire array, or for example that is the last element, just as we saw in case of 10 over here, we can just return -1 for that, right? So that's what we need to do entirely. I hope you would have understood it now. Now maybe you can just pause this video and try to think of a solution. It can be of any time complexity, but just try to come up with a solution, and once you're done, you can just come back and check the solution here. So now to solve this particular question, see, a naive approach and a very obvious one that would come to your mind would be that, for every element over here, I can just traverse the rest of the elements of the array, and I can stop, the moment I see a greater element than the current one. So for example, in my first iteration, I will just fix 4 over here, right, in my outer loop, right? And then I will traverse all the remaining elements of this particular array, right? And the moment I see a number which is greater than the current element, that is 4, I will stop over there, and that will be my output. That will be my result for the current element, because I'm only interested in the immediate greater element, right? So once I find the first greater element while traversing the rest of the elements, that will be actually my output for that particular current element, right? So that's what we can keep doing for every element over here. But since we are going to use 2 nested loops over here, the time complexity will become order of n square over here, right? So that won't be very efficient. So let's try to think of an efficient solution over here, right? So now one observation that we have over here is that since we need to find the next greater element, right? So that means we need to find, a number which is greater than the current element to its right, right? For example, if I'm at 4, I need to find what is the immediate greater element which is after 4, right? To the right of 4, right? So that means to know like which would be the immediate greater element than the current element, I should have already seen these elements, right? At any current element. For example, if I'm at 7, I should have already seen these 8, 6, 10, right? To actually figure out which would be the next immediate greater element, right? So one observation is that I definitely have to move from the right to the left. I have to scan this particular array in the reverse order, right? Starting from the right, I have to traverse towards the left, right? And then I might be in a position to say that at any given index, what would be the next immediate greater element that I have already seen, right? So that is one observation. That is one technique that we can actually follow, right? Now, if you see, so if I start scanning this particular array from the right to the left, first I will encounter 10, right? So by default, since there is no next element to 10, its result would be -1, right? The next immediate greater element would be -1 for 10, right? When I move to 6, it would be 10, right? As you see over here. When I move to 8, it would be again 10, the next greater element, right? So I list 10 over here, right? Now when I move to 7, the next greater element is 8 itself, which is the next number, right? So it will be 8 over here, right? Now just think for a minute that I don't know what is going to come ahead, right? After 7, right? For example, let's say we don't know this is 9, this is x, right? So what are the different possibilities for x, right? One is that x, when compared to the next number, which is 7, is actually greater than 7, right? Or let's say, first of all, in the first case, it is lesser than 7, right? If x is lesser than the next number, which is 7, then of course the next greater number to x would be 7 itself, right? And we can list 7 over here, right? But now let's say x is actually greater than 7, right? Those are the only two possibilities, right? So for example, now x is greater than 7. So in that case, what I can do is I can then check, or I can compare this x with the next greater element to 7, right? Whichever was the next immediate greater element that I have already found out, I can compare that element, that number, with x. Now again, there are two possibilities. One is that maybe x is lesser than that next immediate greater element to 7, right? In that case, the next greater element to x also would be that number, right? Or x is greater than that number. If x is greater than that number, then what I can do is I can then compare it with the next greater element of that number, right? Which was the next greater element of 7 actually, right? So if you see in this example, if my x is over here, first I will compare x with 7, right? Now if x is greater than 7, then I will compare x with the next greater element of 7, which is 8. So now, for example, if x is also greater than 8, right? Then I will compare x with the next greater element to 8, which is 10, right? And again, if x is greater than 10 also, then, I don't have any other element to compare. And so I can just conclude that there is no next greater element than the current element, which is x. And my output for this particular number would be -1 over here, right? And at any point, in this sequence of comparison that I did, whenever I find that x is lesser than a given number, then, that number will be the next greater number to x, right? For example, if x is 9 over here, right? So let's say 9, when we compare with 7, so of course 9 is greater than 7. So then I will have to compare it with the next greater element of 7, which is 8. So 9 is again greater than 8. So now I will have to compare it with the next greater number of 8. So now that is 10. So I will compare 9 with 10 now, right? Now 9 is less than 10, right? So that means the immediate next greater element to 9 would be 10, right? So that's what I need to do. I have to compare the current number, first of all, with the next number, immediate number, and then based on, whether it is lesser than or greater than the next number, I have to compare it with the next greater element of the next number, and then so on, right? I have to just keep following that sequence. And also, if you observe the sequence of these comparisons, first I'm comparing the current number with the immediate next number. Then if that doesn't work, then I'm comparing it with the next greater number, and so on, right? Which means I'm comparing first with the last number that I have seen, right? If that doesn't work, then I go up the ladder, right? Which means I'm comparing in last in first out sequence, right? In a LIFO sequence. And to figure out which data structure we would use, stack would be a best fit for it, because stack also follows a LIFO order, right? So let's try to backtrace this using a stack. So now, for example, this is my array, right? As we have seen, and this is my stack, right? So stack is currently empty and output is currently empty, right? So now, as we discussed, we will start traversing from the right and we will keep going towards the left, right? So now when I'm at 10, right, I will just push 10 into the stack, right? And the output for 10 would be -1, because as we have seen, since there is no number next to 10, it will be by default -1, right? So this one is easy, the first number, right? Now when we move to the next number, which is 6, like this. So again, the next greater number to 6 is 10, right? And how did we arrive at it? We would be comparing 6 with 10, which was originally present in the stack, right? And since, 10 was greater than 6, we just added 10 over here as the output of 6. And then we also pushed the current number, which is 6, into the stack, right? So that when we move to the next element, we can compare that next element with 6 first, right? So now when we move to 8, right, we will first compare 8 with 6. Now since 8 is not lesser than 6, it is greater than 6. So we will just pop this 6 out of the stack, and then we will compare 8 again with the top of the stack, which is 10, right? And now since 10 is greater than 8, we will get the output for 8 as 10, right? Now when I go to 7, again first I will compare with the top of the stack, which is 8. Now since 8 is greater than 7, so my output for 7 will be 8 over here, and then I will push 7 over here to the stack so that it can be compared with the next number, next upcoming number, like this, right? Now when I'm at 9, again I will compare 9 with the top of the stack, which is 7 currently, right? And now since 9 is greater than 7, so this is invalid. So I will just pop 7 out of the stack, right? I don't need 7 anymore because I have got a greater number than 7, right? Then I will compare 9 again with the new top of the stack, which is 8. Again 9 is greater than 8, so I will pop 8 as well out of the stack, right? And now again I will compare 9 with the top of the stack, which is 10. And now if you see, 9 is lesser than 10, so my output for 9 would be 10, right? And then I will just push 9 again into the stack, right? Now when I move to 2, again I will compare 2 with the top of the stack, which is 9, right? And of course 9 is greater than 2, so my next greater number for 2 would be 9, right? And I will push 2 to the stack for the next number to be compared with, right? Now when I come at 5, again I will compare 5 with the top of the stack, which is 2. Now 5 is greater than 2, so I will just pop 2 out, right? And of course I will just push 5 into the stack, and my output for 5 would be 9 because 9 is greater than 5, right? And now when I move to 4, I will again compare 4 with the top of the stack, which is 5. And of course 5 is greater than 4, right? So my output for 4 would be 5 over here in my output array. And then finally I will just push 4 into the stack like this, right? And since now I have exhausted all the elements of this particular array, right? So I will just stop over here, and this is my final output. So this is what we need to do. This is the algorithm that we need to follow, right? We will be making use of a stack data structure over here in this way. I hope you understood it well. And now see, talking about the time and the space complexities over here, at maximum, we will be actually appending, or we will be pushing every element to this stack once. And at maximum, we will also be popping out that particular element once, maximum, right? So we will be doing these operations in the worst case for every element, right? So we will be actually doing 2 operations for every element in the worst case, right? So in the worst case, the time complexity will be order of 2n, which is essentially order of n itself, right? So that's why the time complexity will be order of n over here, right? And talking about the space complexity, since we are using an extra stack over here, it would be order of n, right? So time and space complexity both will be order of n over here for the efficient solution, right? So now let's code this particular solution. All right, so let's code this particular solution. So I will just declare a function, and I will just name it as next larger element maybe, like this. And this will accept the input array, right? And first of all, what I will do is I will just capture the length of this particular array in a variable n, right? And now I will just, declare an empty stack over here, and I will be using the array implementation of the stack, right? And also I will just declare an empty array to hold my final output, right? Now what I will do is I will just start traversing this particular input array in the reverse direction, right? So I will do for I in range n minus 1 minus 1 till minus 1, right? That's how I can just traverse this particular array from the right to the left, right? And now what I will check is that while my stack is not empty, first of all, right? Like this, and the top of the stack, whatever I have currently in my stack, if that is lesser than equal to my current element, right? That's what we have to check, as we have seen already, right? If, for example, my top of the stack is actually lesser than or equal to the current element, it would mean that I have to now compare with the next element, right? I have to pop out the current top element of the stack like this, right? And then I will be comparing with the next top, right? The new top, right? And I will keep doing this till actually my stack becomes empty, right? Or, I find a greater element than the current number. That's where I'm going to stop, right? So basically that's what I'm going to do. And once I'm out of this particular loop, I will just use a local variable over here, greater, right? And in this, I will be assigning the top element, whatever is the current top of the stack, right? In case my stack is not empty, right? And if my stack is empty, in that case, I will just assign -1, right? And why would I assign -1 if my stack is empty? It would mean that I would have gone through this entire loop without actually finding even one number which is greater than my current number. That means there is no greater number than the current number in the entire array, which is next to the current element, right? So that's why I will be assigning -1 in that case if my stack is empty. If my stack is not empty, then whatever is the current top of the stack, that will be the next greater element, right? And that's what I will be assigning to this local variable, which will be keeping track of that next greater, right? And this next greater or this greater variable, I will just append in my result, right? So I will just say res.append greater, right? And also I will push the current element to the stack for it to be compared with the upcoming next elements, right? That's what I will be doing over here, right? And then once we are done traversing all the elements of this particular array in the reverse order, right, we will just return the res array, right? But before returning, we will just reverse its order, right? Why would we reverse the order of this particular resultant array? Because if you remember, we have been traversing the input array from the right to the left, right? But then while appending, we have been appending from the left to the right. So actually the output of each of the element of my input array has been actually reversed when I was appending in my resultant array, right? Because obviously I have been traversing the input array from the right to the left, but I have been appending from the left to the right in the output array, right? So before returning, I just need to reverse this particular result array, and that would be my final output, right? So now maybe what we can do is we can just quickly test this particular solution on the same output that we had seen. So let me just copy that particular array quickly over here like this, right? And now what I will do is I will just print the output of this particular function next larger element when called on this input array like this, right? And this should give us, the same output. Let me also copy the output from there so that, we can compare with it, right? So this should be my output, right? Let's see if we get this or not. So if you see, this is my output, right? 5, 9, 9, 10, 8, 10, 10, -1, right? And over here also, if you see, the output that we were expecting was 5, 9, 9, 10, 8, 10, 10, -1, right? So that's the correct solution. I hope you understood it well. And now I will see you in the next question. Thank you.